Excellent! Now we're going to try to simplify some ratios of polynomials. So think of this analogous as reducing fractions. We're going to be like reducing fractions but with these multivariate polynomials. So for our first example, I have 20 u to the fifth y to the sixth over 10 u cubed w to the sixth plus 25 u to the fourth. Okay, first stage. Numerator is a monomial, so there is no factoring that can go on here. We're just going to keep it as 20 u to the fifth y to the sixth. On the bottom, however, there is some factoring that can occur. So it looks like we're going to have to pull out our GUKF, right, our greatest common factor. So the greatest common factor between 10 and 25 would be, well, I guess the number 5. Notice that 5 goes into 10, 5 goes into 25. Now there's a u cubed over here and a u to the fourth over here. So in terms of common factors that we can pull out of both, we pull the least of the exponents. So we're going to pull out a u cubed that will cover on both of the pieces. And then with respect to the w that's floating around, there is no w on the right-hand side of this binomial, so we can't pull out any kind of copies of w. So what's left over when we pull out the 5u cubed on the denominator? Well, 10 would leave a 2, because 5 times 2 is 10. U cubed was completely pulled out, but the w to the sixth was untouched. Separated by plus sign. 5 pulled out a 25, leaves a 5, and then there were 4 copies of u, and we only pulled out 3 of them, so therefore we have to have a u that is left over. Okay, so that stage is the pulling out or factoring a monomial out of a binomial. And now we get to do our magic. U cubed on the bottom, u to the fifth on the top, so that's going to leave a u squared. There were 5 copies on top, 3 copies on bottom, 3 copies reduced with 5 to leave me with 2. And the numbers 20 and 5 reduced to become a 4, or a 4 over 1 if you prefer. So the final answer to this question is going to be 4, only u squared, y to the sixth, over the part that's in green because it was untouched, 2w to the sixth plus 5u. Okay, pause the video and try this problem. 4u to the fourth y squared minus 2u to the fifth over 4u squared x to the fifth. This should have felt pretty similar to what we did before. However, this time we flipped things in a different order. This time, the denominator is untouched. It's the monomial, 4u squared x to the fifth. In the numerator, the common factor between the numbers 4 and 2 would be the number 2, and then we have u to the fourth power, because that's the lowest exponent on the u's between 4 and 5. The y is untouched. So what's remaining after we pull out this monomial from the binomial is the number 2, no copies of u, y squared, subtracted by 2 was completely pulled out. Only 4 copies of u were pulled out from this 5, so we do have to leave a u in there. And that's it. So now 2 and 4 reduce by 2. U to the fourth and u squared are going to reduce, leaving u squared in the numerator because the 4 copies on top and the 2 copies on the bottom. And so hopefully when you work this on your own, the final answer you got was something like u squared multiplied by 2y squared minus u all over 2x to the fifth.